This question is from GATE 2015 Mechanical Engineering paper, set 2, question number 31. A cantilever beam OP is connected to another beam PQ with a pin joint as shown in the figure. A load of 10 kN is applied at the midpoint of PQ. The magnitude of bending moment in kilonewton meter at fixed end O is. Let's start by drawing the free body diagram of this beam. So we'll first draw the part OP and the part PQ separately. This is OP, this is PQ. At P there is an internal hinge. Now rotation here is allowed. So the member about this internal hinge can rotate and therefore the moment at this hinge will be 0. This is not a moment resisting hinge. So at P we can draw the reaction RP like this. For the load 10 kN it is offering a reaction, and same we will have to draw equal and opposite in order to balance the joint. So external load on this is 10 kN at center. This is RP and this is the reaction at support Q, which is RQ. Let's draw the reaction at the fixed support. We have a reaction force RO and a moment that resists the load carried over to part OP, which can be assumed to be anti-clockwise in the first. We have to find this moment, which is the unknown. Moment at O is what we need to find out. So we can use equilibrium of forces for part PQ. We use summation Fy is equal to 0. Hence we have RP and RQ both are upward. So let's take them positive. RP plus RQ. 10 kN is downward, so we can take minus 10 kN, which on going to right hand side becomes positive, is equal to 10 kN. So we have this equation, but we need to find RP, so we need one more equation. We can calculate it by taking moment about point Q. So if we take summation of moment about Q is equal to 0, the equilibrium equation, we have 10 into 0.5, 10 into 0.5 is the anti-clockwise moment, minus RP into 1 is the clockwise moment, is equal to 0. This gives us RP as 5 kN. You can use the shortcut of symmetry also here. The trick is 10 kN is applied at center of PQ. So the reaction will be distributed equally among the two supports, and hence RP will be equal to RQ will be equal to 10 by 2. That is 5 kN. This is a shortcut that you can use and take the advantage of symmetry. Symmetry of the beam as well as symmetry of the loading. Second part, once we have found out RP, we know the load that is acting at P, the reaction that is offered by P. This reaction will cause a reaction moment at O also. So we can take this RP as an external point load at P and consider this as a cantilever beam which has a free end P. So if we consider for part OP, now the only load acting in part OP is RP. RO is equal to RP is equal to 5 kN. Now RP and RO are creating a clockwise moment. These loads are creating a clockwise moment with the distance between them as 2 meters. They'll create a moment of 2 into 5 kN. To resist this clockwise moment, anti-clockwise moment will be generated by the fixed end because there is no other entity resisting this moment. The moment that is resisted is fully resisted by the fixed end. Hence, moment about O will be an anti-clockwise moment. We have assumed it to be anti-clockwise. Hence, it will be positive. So, it will be equal to 5 into 2, that is 10 kN meter. We have multiplied 5 kN to 2 meters. So, the unit becomes kilonewton meter. Let's write the answer. We have the options given. Among these options, we have in kilonewton, the magnitude of bending moment is option C, 10. To learn more about beams and bending moment in beams, you can refer to the NPTEL video, lecture 10, beams 1, from the course Engineering Mechanics by Professor K. Ramesh. He is from Department of Applied Mechanics, IIT Madras. I hope this solution will help you clear your doubt. Thank you.